Hello everyone, and welcome to Quantifii's presentation on the basics of calculating and estimating brickwork. In this presentation, we will discuss methods used in Brickwork Takeoffs in order to calculate the area of brickwork. Be sure to watch our other brickwork presentations for further information on Brickwork Takeoffs and various brickwork cost analyses. Continuing from our previous presentation on the volume of mortar, the next step in calculating the number of bricks and volume of mortar required to complete your structure is to find the wall centerline. Once determined, the centerline can then be multiplied by the brick wall's height to arrive at a total square meter area of brickwork required. The calculation for this is explained in the following two methods below. Let's consider this small bedroom addition. The brick wall will be built off a strip footing. The height of the foundation brickwork is 510 millimeters, and the superstructure brickwork 2.45 meters high, for a total height of 2.96 meters. Method 1 involves measuring the internal and external visible walls and dividing the answer by 2 to calculate the centerline. The internal wall's horizontal length is 10.78 meters and the vertical length 10 meters for a total of 20.78 meters. Multiplied by 2 sides for a total length of 41.56 meters. To note, only visible walls should be measured. That is, we exclude the concealed corners. The external wall's horizontal length is 11.32 meters, and the vertical length, 10.54 meters, for a total of 21.86 meters. Multiplied by 2 sides for a total length of 43.72 meters. Therefore, open bracket, 41.56 meters, plus 43.72 meters, close bracket, divided by 2, returns a centerline of 42.64 meters. The centerline of 42.64 meters, multiplied by a height of 2.96 meters, amounts to a total brick wall quantity of 126.214 square meters. Method 2 involves measuring only one wall and applying a formula to shift the calculation to the centerline. Firstly, we'll need to determine the exterior wall's length. Once we have calculated the perimeter, we can use the following calculation to decrease the perimeter length from outside to the middle, that is, the centerline. External perimeter, less, open bracket, 4, times 2, times half, times the wall width, close bracket. Essentially, we deduct half the wall width, twice, for each corner. The above is further explained in the example to follow. In measuring the perimeter, you will note external corners have been overlapped, and internal corners excluded. The difference between the external overlaps and internal exclusions must always equal 4. This number is used in our formula, in addition to deducting half the wall width, twice. Therefore, our formula will read as follows. External perimeter, less, open bracket, 4, times 2, times half, times the wall width, close bracket. The external wall's length, as before, is 43.72 meters. We can then deduct 4 by 2 by half by the wall width of 270 millimeters. This gives us a centerline of 42.64 meters. The centerline of 42.64 meters, multiplied by a height of 2.96 meters, amounts to a total brick wall quantity of 126.214 square meters. Moving on to adjustments for openings. After calculating the total area of brickwork required, openings such as windows and doors must be deducted so we can ascertain the final quantity of brickwork required. The building has 3 windows, which we need to deduct. For this exercise, we can assume the windows are 800 millimeters wide by 1.2 meters high. Therefore 2.88 square meters must be taken off the total brickwork area. The door opening we are going to assume as 900 millimeters wide by 2.1 meter high. Therefore deducting a further 1.89 square meters off the total brickwork area. The total deduction amounts to 4.77 square meters. We can now calculate the quantity of brickwork and materials required for the proposed addition. The total square meters of brickwork equals 126.214 square meters. Less adjustments for openings of 4.770 square meters. Therefore the final brickwork quantity amounts to 121.444 square meters, which we can round up to 122 square meters. The brick wall thickness of 270 millimeters, as per the previous presentation, amounts to 104 bricks per square meter, with a mortar volume of 0.035 cubic meters per square meter. So, the total number of bricks required is 12,688 bricks, say 13,000, as bricks are normally sold on pallets of 500 bricks. The total volume of mortar required is 4.27 cubic meters, say 5.0 cubic meters. And that concludes Quantifii's presentation on takeoff methods and quantification of brickwork. Thank you for watching. Be sure to watch our other videos on the basics of brickwork and various other topics in the built environment.